Many enterprises are currently seeing flat or negative returns on their AI investments because massive agentic capability is being forced through narrow, legacy organizational structures. Organizations are falling into the faster horse trap. They take frontier orchestration tools and bolt them onto legacy frameworks like Agile Sprints, SAFe, and the V model. We are currently instructing autonomous agents to write requirements documents, test plans, and architectural diagrams that exist solely for human approval gates. These traditional lifecycle phases were designed to manage human cognitive limitations. For a non-human workforce, they function as artificial bottlenecks. Captured productivity depends on moving past AI-assisted versions of old processes and adopting an AI-native framework. The traditional V model relies on phases, requirements, high-level design, and detailed design to provide handoff points and catch drift before it compounds. Agentic platforms act as probabilistic compilers, accepting precisely engineered intent and producing verified, deployed software as a single output. Forcing this compiler to pause and produce intermediate design artifacts is expensive theater. It consumes computing tokens and calendar time just to satisfy an outdated manual checklist. In this model, the fundamental unit of work shifts away from the individual user story or the Jira ticket. Capturing the efficiency of the machine requires leaders to abandon human-scale task delegation in favor of the value lump. Modern software engineering is built on the assumption that massive epics must be broken down into stories, tasks, and subtasks. This is a direct response to Miller's Law, which established in 1956 that human working memory can only hold approximately 7 items simultaneously. Agile decomposition is a coping mechanism for biological limits. We use 2-week sprints because it's the largest complexity a human mind can hold. This creates a decomposition tax, 16 tickets created before code is written. Agents operate without constraints, holding entire requirements simultaneously. This capability enables the value lump, a singular unit of business value described by intent, where the machine handles all internal decomposition. Applying agile decomposition to an agent orchestra artificially handicaps the machine, forcing it to operate at the speed of human working memory. The argument for larger units of work is driven by the mathematical cost of human coordination. Classical coordination overhead grows quadratically with team size, spending more time in meetings than writing code. Agentic cost scales linearly, driven only by tokens. This creates a crossover point. At the service level, the human cost of planning exceeds the token cost of agent execution. Beyond this threshold, traditional decomposition becomes a financial liability for the organization. If user stories are obsolete, we need a new artifact to guide the machine. The living specification acts as this new primary artifact, a precise, machine-readable contract of intent. Development has traditionally been a one-way street, from a pristine template towards accumulated technical debt. Agentic engineering, however, creates a cyclical relationship. Changes flow bidirectionally between the living spec and the generated code. Engineers no longer edit source code, they update the specification's intent. The machine then recalculates whether to refactor or rebuild the module entirely. The living specification serves as the primary asset, while the codebase functions as a regenerable byproduct. This bidirectional model addresses the most expensive problem in enterprise IT, legacy code. For 30 years, the Netscape failure convinced organizations that system rewrites were too dangerous to attempt, making incremental refactoring the only rational choice. But refactoring carries structural taxes. It preserves historical compromises, protects undocumented shadow intent, and eventually leads to terminal migration fatigue. We can now replace these taxes with intent archaeology. Agents scan legacy code and documentation to extract a clean living specification of what the system actually does. Once that intent is extracted, agents can rebuild the system from scratch, utilizing edge-first convergence to ensure the new system matches the required external behaviors. Because token costs are falling while agent speeds are rising, rewriting a legacy system is now an order of magnitude cheaper than incrementally refactoring it. Software maintenance has reached a turning point. Rebuilding is now the default economic strategy, and refactoring is a specialized fallback. If cognitive limits and coordination costs are removed, the only remaining constraint on software engineering is our own ambition. Traditional human ambition naturally scoped itself to single features because that was all a human team could reasonably coordinate. Agent fleets operate without coordination overhead, allowing them to absorb entire platforms and multi-domain ecosystems at once. Each delivered value lump proves the machine's capability at that scale, which immediately redefines the starting point for the next broader specification. This continuous expansion pushes engineering ambition from platforms into entire business ecosystems. Engineering leaders historically believed they were limited by technology, when they were actually limited by the need to decompose work for human minds. The role of the engineering leader is shifting from managing human capacity and velocity to pricing raw investment in token budgets. The engineer evolves into the conductor, responsible for writing the score for a non-stop orchestra of agents. This new role prioritizes the precision of the living specification, moving past the historical habit of controlling scope creep. User stories functioned as the essential bridge for human-centric teams, but intent-driven creation now defines the engineering pipeline. The machine does not decompose. Stop thinking in stories, think in value, and write the whole score.